Kids, I'm going to try this again using a Mac. I've never done this, but apparently my microphone on my other computer chose this time not to work. If you listened to my first video, you heard that. The pen option on the Mac is not quite the same, so forgive me for lots of mess ups here. I tried to explain I'm not there because I'm on my way to Boston to see my older daughter, Devin, not the oldest one that just had the baby, but the college daughter, Devin, play in the NCAA softball tournament. So your quiz will be tomorrow on just circles and ellipses, not anything that we're doing today. Your homework is a handout that I hope Ms. Petulante is able to get to you. If not, it is available for download. Okay, and I also attached it to the email that I sent you. So what's nice about this warm-up is that it is just name the conic. You don't have to do any math, you just have to name it. Your choices are circles, ellipses, or parabolas. Since the coefficients of the squared terms here are different, A does not equal C, neither one of them equals 0, and they are both positive or both negative, so they both have the same sign. Therefore, this is an ellipse. This is the naming. I've just done the naming. The justify part is right here. That's all you have to write for justify. So notice for the next one, the coefficients of the squared terms are the same. A is equal to C, neither one of them equal to 0. Therefore, this is a circle. Again, this is the naming, this is the justifying. The next two I put here, which are kind of silly, right? This is the same equation that you just had, but with 0 as a radius. I wouldn't really put this on an assessment. And remember, this warm-up would not be on tomorrow's quiz. This is a degenerate circle, right? The next one I put on purpose because I don't want you to just look at coefficients. It's the coefficients of the squared terms that matter. Neither one of these is squared. This is a diagonal line from Algebra 1 in the beginning of this unit. Right? That's also technically a degenerate conic, but that again isn't something that is interesting to us. This one, and this one are interesting. And the reason this last one is interesting, this is our new one, is because A is 3, but C is 0. There is no y squared term. There is a y term, but not a y squared term. This is neither an ellipse nor a circle. This is a parabola. Remember, we are again working from the general equation, ax squared, no b term, right, because that's 0. Oh, this is difficult to do driving in traffic. Yeah. Doing my best. Plus cy squared plus dx plus ey plus f is equal to 0. It is the squared terms and their coefficients that name that conic. So remember, your homework is a handout. I won't check it till Wednesday, but you will have more homework on Tuesday. But I won't check the parabola homework till Wednesday, so in case you want to get ready for your quiz. And that handout is either going to be given to you by Miss Petulante or is going to be, it's attached to the email I sent you. It's also on the Canvas handout. It's just called AAF Parabolas homework. All right, so you want to get out your notes. And write this in your notes, what we've just said in the warm-up, but I want you to have it in 2 places. If A is equal to C and neither one of them is equal to 0, you have a circle. If A is equal to C, neither one of them A is not equal to C. Neither one of them are equal to 0, but they're both positive or both negative, you have an ellipse. Today, if either A or C is equal to 0, you have a parabola. And on the unit test, not again tomorrow for for circles and ellipses, but on the unit test when there's parabolas, more students make mistakes with the parabolas than they do with the other conic sections, which are new. And I think that's because they assume that they know everything there is to know about parabolas, so they don't really study up on them. But there's a lot of parabolas information that you did not know. So, firstly, the general form of a parabola, there's really 2 of them. There's one when the parabola, when there's no y squared term. When there's no y squared term, you have an up or down parabola. There's also the parabolas when you have no x squared term. And when you have no x squared term, you don't have a function. You have a parabola that either opens right or left. We will have no diagonal or tilted parabolas in this, right? We will have no parabolas that, for instance, look like this. That's if you have the rotational term. Our parabolas will either be up and down or right and left. There's a picture of a whole bunch of parabolas. And again, we will only have the right and left and up and down ones. Now ignore that green line for the minute. That is just, I saved a previous PowerPoint presentation where this got saved before I could erase it. So ignore that green dotted line. The geometric definition of a parabola is defined as the set of all points in a plane that are the same distance. Same distance from a fixed point as they are from a fixed line. Now this fixed line might be horizontal, or the fixed line might be vertical. It will never be diagonal. There's my fixed point. It's a star, and that fixed point is called a focal point. And the focal point is, yes, like the focal points of an ellipse, but an ellipse has 2 focal points. Remember, a circle really does 2. They're just on top of the center. But a parabola only has 1 focal point. My fixed line is horizontal for the first example. That fixed line is called a directrix. And again, for my example, my directrix is horizontal. Bumpy road, bumpy road. Crazy. Horizontal. Now, in order to find all the points that are equidistant from this point and this line, I need some geometry. And we're not going to do that. We are just going to find the point that is halfway between the focal point and the directrix. That is the only point in the plane where the shortest distance is equal, right? Can you tell that the distance from that blue point to the focal point and to the directrix line is the same? There's distance 1, there's distance 2. Since those distances are the same, and it is the shortest possible distance where this is true, they call those distances P. So the entire distance from the focal point to the directrix is 2P. The distance from that special point to the focal point is P, and the distance from the from the point to the directrix is P. Think P, shortest possible distance. That blue point is on the parabola. The focal point is not on the parabola. The directrix is not on the parabola. That's why you never saw them before. This is a special point, though, called the vertex. Right? Now, there are lots of other points that are also the same distance from the focal point as they are from the line. Just none of them is the shortest. So let me sketch back in. The vertex is here. And there are lots and lots of other points that are equidistant. And this is hard to draw. Forgive me. Every point on this sad parabola is the same distance from the focal point as it is the line. Right, see this point here? It is the same distance from the focal point as it is the line. So what if I have another focal point over here on the right? You see another star. This time, I'm going to draw another directrix, but the directrix is vertical. Can you see the picture where the vertex of this parabola is going to be? Since the directrix is vertical, the parabola always goes away from the directrix, and captures the focal point. The vertex is a special point on the parabola that fulfills the definition of being halfway between sorry, ignore this other point here. That's the vertex. There is the distance P, which is the shortest distance from any point on the parabola to the directrix, and the shortest distance from any point on the parabola to the focal point, and that shortest distance is always going to be called P and is always going to be from the vertex. So any point on the parabola, again, any point on this parabola is the same distance from the focal point as it is from the directrix. The vertex is just the one with the shortest possible distance. So you kind of see back over at the parabola that opens up, there's a point on the parabola. I've drawn that yellow distance to the focal point. That distance is the same as the distance from that line on the parabola. Distance 1, distance 2, they're equal. I can show you this definition and get the graphing form using Pythagoras, right? The distance between, right, on a plane is just the Pythagorean, the distance formula, which is just Pythagoras. Remember, P represents the shortest possible distance. So these distances are not equal to P, right? Because this point is not the shortest distance. P is only associated with the vertex, which is the shortest possible. Now, I don't think on my Mac this animation sadly doesn't work. I don't think. Oh yes, it does. There we go. How to create a parabola. You take a focus, a directrix, halfway between is the vertex. That first distances were P, right? That blue and yellow line are not P unless you're talking about now at the vertex. Blue and yellow, not P. P. Oh, missed it. P. There you go. All right, the standard and graphing form that again comes from using the distance formula and that geometric definition of a parabola, there's two cases. This is really just one case. I just wrote it twice so that you would see right? This is the up-down parabola, right? The only difference being that this 4 is positive if your parabola opens up, and the 4 is negative if your parabola opens down. And you might be thinking to yourself, why is there a 4? Well, again, if I had time, I would show you the derivation of the graphing formula. It just comes from the distance formula. Remember, there's that distance P from the vertex to the focal point, the distance P from the vertex to the directrix, that's 2P. Think about the distance formula, you're squaring things. That is where the 4 comes from. Now, you are used to seeing, let's do a time travel back to function land. When we were in function land, not conic land, you dealt with parabolas like this. Y was equal to A times x minus the x coordinate of the vertex squared plus the y coordinate of the vertex, right? And if I wanted to get the y back over with the y, I would say y minus the y coordinate of the vertex is equal to this dilation factor, x minus the x coordinate of the vertex squared. You need to know that these equations that you got in Algebra 1 and the beginning of Algebra 2 are manipulations of these ones. This is fake. We own these equations here are manipulated for function land. But the parabola started in conic land. It didn't start in function land. Did you ever wonder why when A got larger, the parabola got skinnier, and when A got smaller, the parabola got bigger or wider? That always bothered me until I learned the actual definition and the actual graphing form of a parabola. Notice what is different over here from function land. Where's the squared group? Right? The squared group is on the other side of the equation, on the left side. Notice the squared group is over here. The x stuff, whoops, I'm sorry. Notice the squared group is on the right side of the equation. And the linear stuff, we don't usually write that. We don't usually even write parentheses around the y stuff. But notice the dilation factor is here with the linear stuff. In function land, the dilation factor was over with the squared stuff. Well, I'm going to go ahead and put this as a group. Put it to the first. If you divide both sides by A, right? A divided by A goes away. You now have the dilation factor, 1 over A in front of the linear stuff. 4P is 1 over a. So you started with 4p, and in reality, they divided both sides by 4p to get the dilation factor over with the squared stuff. So now, when 4p gets bigger, the parabola gets wider. When 4p gets smaller, the parabola gets skinnier. Ah, life makes sense. So remember, this is one form for your uppy-downy. And then here's your next forms for your righty-lefties. Notice the difference is that for righty-lefty, the y stuff is squared and the x stuff is linear. But remember, the dilation factor always goes over with the linear stuff when we're in conic land, right? This is conic land. Remember, you're used to seeing the dilation factor in front of the term called and that it's called A. The actual graphing form is derived from the geometric definition. The algebra 1 form is just a manipulation. They just divided both sides by 4p. That's all. So let's try to graph and label from graphing form. So copy this equation down, copy your axes down, and of course mark your axes with an x and a y. Because the y is squared, this is going to be not an uppy-downy. This is not going to be a function. Now for parabolas, you are responsible for labeling the vertex, which is in red, the axis of symmetry, which we called the line of symmetry, right, the LOS, and the x and y intercepts. That's all old news. In blue are your new ones, the directrix and the focal point. Now remember, for tomorrow's quiz, you don't need x and y intercepts. You don't need x and y on circles, and you don't need x and y intercepts, not on your ellipses, right? Only on parabolas do you need x and y intercepts. Only on parabolas. So, because the y is squared, I know this is a righty and a lefty. The dilation factor is over with the linear group. That's a 1. I pull the vertex out. Remember, you still want the x coordinate of the vertex first. And the x coordinate of the vertex is over with the x. So, and the y coordinate of the vertex is with the y. So I graph and I label this point. -1, 2. The dilation factor is 8. And remember, the dilation factor is 4 times p. Since 8 is positive, the 4 is positive. So I know that this is not a lefty, right? Since the dilation factor is positive, I'm a righty. So I'm going to open to the right. Since 4p is equal to 8, p itself is equal to 2. So I take the vertex and I go right 2 to the focal point. And if I went right 2 and I was at -1, I'm now at 1, 2. And the directrix is going to be 2 units behind the vertex, right? That's because the dilation factor was positive. And of course, the directrix has an equation. You need to label it with an equation. Ax is equal to, if the vertex was at -1, this is now going to be at -3, right? So now I have the y-intercept up here, but because this opens to the right, How many y-intercepts do I have? 2. Get it? Y is squared. 2 x-intercepts. X is to the first, so I've got how many x-intercepts? Only 1. That's not a coincidence. Oh, I kind of missed there, didn't I? Sorry. Just like before, I have the axis of symmetry, and the axis of symmetry will always be perpendicular to the directrix. Now, my axis of symmetry, since I'm opening to the right, is horizontal, so the equation of my line of symmetry is y is always the y coordinate of the vertex. So I've labeled the vertex, I've labeled the directrix with an equation, I've labeled the line of symmetry with an equation, I've labeled the focal point with its coordinates. I just need the x and y intercepts. How do you find an x and y intercept? Anytime, any place, anywhere? You use the equation, right? So I'm going to make x equal to 0. Oops, I lost my... Gosh darn it. Gosh darn it. The Mac doesn't preserve the annotations when you... Also doesn't do some of my animations either. Alright, so you already have all those labels. So I put 0 in for y. And solve. Oops, first I think I did 0 for x. That's what I did first. Don't square this out. Y minus 2 squared is equal to 8 times 1, which is 8. Use the inverse operation. What's the inverse of squaring? It's not square rooting. It's plus and minus square rooting. You have 2 y-intercepts. So y minus 2 is equal to plus or minus the square root of 8. Some of you will write that as 2 root 2. Fine. You don't have to do that for me. Getting y by itself, y is equal to 2 plus or minus the square root of 8. So when x is 0, y is 2 plus the square root of 8. When x is 0, y is equal to 2 minus the square root of 8. Now make y equal to 0. Define the y. Sorry. Make y equal to 0. Drawn this like 5 times now, right? Make y equal to 0, and you have negative 2 squared is equal to 8. Don't distribute the 8. Trying to get x by itself. 4 is equal to 8 times x plus 1. Divide both sides by 8. You get a half is equal to x plus 1. And now subtract 1. X is equal to negative a half. Right? So you copied down all those other labels, I hope. All right, this time they're not asking us to graph, they're just asking us to transform. transform from general form to standard form. So I only have a y squared, no x squared. So I say to myself, is this an uppy, downy, righty, lefty? Since a is equal to 0, this has to be a lefty, righty, lefty. Right? A right or left, because a is equal to 0. So I have to think about the graphing form. The graphing form of a right-left is y minus the y coordinate of the vertex in a group that is squared is equal to a dilation factor times a group x minus the x coordinate of the vertex. So the first thing I'm going to do to try to match this form is get the squared terms over by itself and the not square terms over on the right. I'm going to factor a 5 out of here and leave room for squaring, completing the square. Completing the square means I'm going to divide that negative 6 by 2 and get y minus 3 to create a squared group. That's not legal though until I take negative 3 and square it and get 9 here. Now y squared minus 6y plus 9 is factored and can be factored as y minus 3 quantity squared. But I'm still not legal up here on this step because I added 9 to the left side of the equation. Psych, you really added 45. So you must add 45 here as well. Now what do I have over here? Negative 11, negative x plus 56. So I'm getting there. Look at the form. I'm here. I've got my y group squared, but this 5 has got to go. Right? Up here on graphing form, there's only a 1 there. There's no 5. So I have to divide both sides by 5 or multiply by 1/5. Before I do that though, I'm going to take this x thing and I'm going to factor out the negative. Why would I do that? Why would I do that? Right? I want an x group, that's why. So I factored the negative out front so that I had a positive x minus a vertex. But don't forget, I divided both sides by 5 or multiplied both sides by 1/5. So I have to multiply the right side by 1/5. Now look what I have. My vertex is 56, 3. Negative, because there's a negative here, negative 4p is equal to negative 1/20th, meaning p, I'm sorry, 1/5. So p is positive 1/20th. This is going to be a very skinny parabola, but they didn't ask me to graph it, thank goodness. Okay, so transforming for a parabola from general to standard form means getting one squared group. Now, once I'm in graphing form, I can tell you what the vertex and p is, so I could graph it from here. So maybe try to pause the video and see if you can sketch these yourself. And then come back and see if you got the same answer as me. All right, so I'm going to do the first one. The first one has x stuff squared with a negative dilation factor. So this parabola opens down. It'll have a focal point inside and a directrix on top. The vertex will be 2, -6, 4 with a negative is equal to -1/4. Therefore, P itself is equal to 1/16. So I'm going to graph that over here. -6/2 is the vertex. I already know that my directrix is above. I'm a skinny parabola. Terrible. I'm going to draw my line of symmetry perpendicular. I know my focal point is going to be inside. My focal point is, my directrix is 1/16 of a distance above. And I'm just going to leave it like that for now. And my focal point is at -6, and the y coordinate minus 1/16. Okay, what is that? So 16/16, 2/16. So what would this be? 33/16, and this would be 31/16, I guess. Oh dear. XY. Right? The equation of my line of symmetry is x is equal to the x coordinate of the vertex, and the only thing I'm missing are my x coordinates, my x-intercepts, and my y-intercept way down here, right? The y-intercept is when x is 0, and the x-intercepts are when y is 0. How do I find them? Well, the x-intercepts are when y is 0. So you go to the equation and make y 0. Notice that x is what? What's the exponent with x? It's in a group squared. There's going to be 2 x-intercepts. Y is 0. -1/4 times -2 is +1/2. Don't square that out. Undo the squaring with the plus and minus square root. So this one is -6 minus the square root of 1/2. And this is -6 plus the square root of 1/2. How do I find the y-intercept? The y-intercept is when x is 0, right? So you have 0 plus 6 squared is equal to -1/4 y minus 2. Do not distribute that -1/4. Multiply, so this is 36 over here. I'm going to multiply both sides by -4. Add 2. Okay. All right, let's see how you did on the next one. So for the next one, whoops. For the next one, y is, for the next one, y is squared. And the dilation factor is positive, therefore this is a right. The vertex, the x coordinate of the vertex is -3, and the y coordinate is 2. The dilation factor is 4 positive because the dilation is 4p is equal to the dilation factor. So p, oh this is nice, is equal to 1. So let's graph this one. -3, 2. This opens to the right, so my focal point is here, and my directrix is behind it. So my directrix is going to be at x equals -4, and my focal point is going to be at -2. I have 2 y-intercepts and 1 x-intercept. My line of symmetry, which is perpendicular. Perpendicular. Y is equal to the y coordinate. So I've got my focal point, my vertex, my line of symmetry, and my directrix all labeled. I just need my intercepts. So I'm going to make y equal to 0. 0 minus 2. When I make y into 0, I'm finding an x-intercept is equal to 4. Don't distribute the 4. X plus 3. -2 squared is 4. Divide by 4. So my x-intercept is -2. To find my y-intercept, I make x equal to 0. Do not square y minus 2. $12 is equal to y minus 2. Do not square y minus 2. Undo. What is the inverse operation to squaring? It's not square rooting, it's plus and minus square rooting. Again, some of you might write the square root of 12 as 4 root 3. Good for you. You just don't have to. Not for me. You'd have to for standardized tests, but not for me. Whoops, that is already a minus, right? So positive 2 plus or minus the square root of, you have to be joking me. So now all that work is going to be gone because we turned a corner. So we had the vertex, we had the line of symmetry, we had the directrix, we had the focal point, we had the x-intercept was at -2, 0, and we were finding the y-intercept, and we had y minus 2 is equal to plus or minus the square root of 12. So y was equal to 2 plus or minus the square root of 12. So when x is 0, y is 2 plus the square root of 12, or 0 to minus the square root of 12. Okay? Now some of your homework problems, I gave you on your homework sheet, I gave you some matching, so I want you to focus on, you know, are you a righty-lefty, uppy-downy, how do you know? And, you know, where your vertex is. And then I've given you some, like, clues, like, here's some, like, what's the focal point in the directrix, and write the equation. But if I ask you to write the equation of a parabola, don't do it in general form, you do it in graphing form. So for instance, if I give you, like for this parabola that we had just done, what if I said, pretend you didn't see this, and what if I said, this is like what's going to be on your homework, what if I said, hey, given a vertex of -3, 2, and a directrix x is equal to -4, write the equation. Well, you say to yourself, -3, 2 is in the second quadrant. The directrix x equals -4 is behind it. Therefore, this must be a righty-lefty. And to be a righty-lefty, I have a y group squared is equal to 4p x group. And you take the information that I gave you, and you put the x with the x, and the y with the y, and then you have to figure out 4p. Well, how are you going to do that? Well, you use the given information, right? You say to yourself, if this is in the second quadrant, -3, 2, and the directrix is only 1 unit away from it, well then p must have been 1. If p is equal to 1, then 4p must equal 4. You know it opens right, so 4p is a positive, so that's how you would get the 4 there. Okay, so I do that to you on your homework. And also on your homework, one of the questions I give you, I don't give you the vertex, I give you the focal point in the directrix to see if you can figure out p. Alright, so I apologize again for the first video being all the audio being messed up, and I hope that I can get this one to work.